All right, in this video, we're going to explore how to find the limit of a function algebraically without the use of a graph. So you don't have a graph in front of you, you're given a function, and you still have to be able to find the limit. That's what we're going to learn how to do today. So here's the idea. Remember, we're trying to find the limit of a function as x approaches c. The first method I always suggest is to plug c into the function and see what you get. So the first thing you should always try to do that a lot of times give you the answer you need is take this c value and plug it into a function. Plug it into the function out. If you do that, several things are going to happen. So once you've plugged the c into the function, one of three outcomes will happen. You'll get a number. You'll get a value, right? This means that you get an actual real value. Square roots are okay. Fractions are okay. Number on top, zero on the bottom is bad, obviously. But anytime you get an actual number, that's your answer. You're done. Simple. Now, the second thing that could happen is you get a fraction with a number on top and a zero in the denominator. So if you get a number on top, any number you want, and a zero in the denominator, this outcome is actually not that bad either. This means that the limit does not exist. Basically, what's happening here is, we've learned this before, you have an asymptote because of that issue in the denominator, and that means you're going to have a, well, does not exist. No limit at that particular value. So keep that in mind. That's another nice outcome. Now, the third thing that can happen, this is kind of the worst case scenario, and that is when you get a zero on top and a zero on the bottom. So this is the double whammy, a zero on top, zero on the bottom. This is where there's going to be some work to be done, right? There is a limit. There is an answer. You're just going to have to do a lot of work to find it. So remember, zero on top, number on the bottom, that's okay. That just means that your equals zero, right? I mean, you're allowed to have zeros on top. That's kind of this first scenario here. Number on top, zero on the bottom, that's not too bad. It means your limit doesn't exist. It's pretty easy. Third case is the double zero. Okay, so when you get the double zero, as I call it, you are just going to have to use some algebra techniques to uncover the problem and get rid of it. So the idea here is there's obviously something going on in the problem that's creating this zero on top and zero on the bottom. You need to get rid of that problem, remove that problem, and then you could find the answer pretty easily. So in this video, we're going to look at three different scenarios, and they're most common how to handle the algebra behind these different scenarios. Okay? So I think what we're going to find is that the case 1 and case 2 mentioned above are pretty simple. It's that third case that's going to cause some trouble. So here's two limits, right? And our goal is to find the limit of 3x minus 5. 3x squared minus 5 as x approaches 4. So, like I said, in any limit problem, the first thing I'd always recommend doing is plug in 4. So that's 3 times 4 squared minus 5. That's 3 times 16 minus 5. And if you need to grab a calculator to do that, that's not a problem, obviously. 3 times 16 minus 5 is 43. I got an answer. I got a number. Well, there you go. That's your limit. The limit is 43, which means as I go from the left, and if I go to the right, as I approach 4, I get to 43. All right, here's another one. The limit is as x approaches 3. First thing I'm going to do is plug 3 in. So I get 3 minus 3 on the bottom. That's 7 over 0. Okay, this is scenario number 2. Number on top, 0 on the denominator. This means that the limit does not exist. What's happening here is that there's clearly a vertical asymptote at 3. And as my function gets closer and closer to 3, I hit that vertical asymptote and the limit doesn't exist. So that's another pretty easy problem. Okay, let's check out this one. Again, first thing I would recommend doing is always plugging negative 2 in. So when you plug negative 2 in on the top, you get negative 2 plus 2. When you plug negative 2 on the bottom, let's say it's going to get a 4 plus negative 10 plus 6. That's going to be a 0 on top, and that's going to be a 0 on the bottom. Okay, so this is the first problem we see where we have the 0 over 0. What we have to do is we have to do some algebra to uncover the problem. So a problem that looks like this, what I would recommend doing is factoring. So let's factor the top, x plus 2, that's pretty easy. On the bottom, let's factor that up, and we get, let's see here, x plus 2 and x plus 3. I believe that is the correct factor. Now look what's going to happen. The x plus 2's cancel. So what I just did is I got rid of my problem. See, the negative 2 on top and the negative 2 on the bottom was creating that double 0. So what's left over is 1 over x plus 3. So now that I got rid of the problem, I could come back and find the limit as x approaches negative 2 of 1 over x plus 3. So basically I got rid of the problem, and now now I'm ready to find the limit. All I got to do is plug in -2, and I get 1 over 1, so there's my limit. My answer is 1. Worked out really, really nice. So all you got to do is get rid of the problem. In this case, I had to do that by factoring, and I was able to find my limit. Very, very simple. So that's one scenario where you have to do some factoring. Okay. Here's another scenario. Now, this is a fraction within a fraction. Let's just see what's going to happen here. Okay, when I plug in 2, that's the first thing I'd always recommend doing is just plugging in that x value. That's going to give me 1 over 2 plus 2 minus 1/4 over 2 minus 2. Well, that's going to give me 1/4 minus 1/4 on top, and a 2 minus 2 on the bottom, and that's a 0 on top, 0 on the bottom. Okay, another scenario where I get my double zeros. Now, this is what I call a fraction within a fraction problem. Once again, there's obviously something going on in this problem that's creating this issue, and I need to simply get rid of it. Here's how we're going to solve this one. What we want to do is reduce this function, right? We want to clean this function up. So the first thing I'm going to do is I'm going to get a common denominator on top. My common denominator is going to be x plus 2 times 4. Okay, this guy right here needs the 4 on top, so I'll multiply by 4. That way he gets that common denominator. I'll multiply top and bottom by 4, giving him the common denominator. This guy needs the x plus 2 on the top and the bottom to get the common denominator. So I'm going to multiply minus 1 times x plus 2. Notice I have to multiply the -1 by the x plus 2. And then instead of dividing everything by x minus 2, I'm going to multiply by the reciprocal, which is 1 over x minus 2. Just cleans the problem up a little bit and makes it look a little bit better. All right, let's clean up that numerator there. That's going to be 4 minus x minus 2 all over x plus 2 times 4 times 1 over x minus 2. All right, let's see here. Let's continue to clean this up here. On top, that's going to be negative x plus 2, right? 4 minus 2 is 2, okay. All divided by x plus 2 times 4 times the reciprocal, remember, which was 1 over x minus 2, okay. That was basically this guy right here. Instead of dividing, I multiplied by the reciprocal. Now, something is going to work here. Now, notice this top. This top doesn't quite look like any of the factors I have on the bottom, but if I take out a negative sign real quickly, it becomes x minus 2. And that's going to be very, very helpful to me in a second here. Okay, because now that I took out that negative sign, making negative times x minus 2, now I see a factor that I can cancel. Here's the x minus 2's that can cancel. Now remember, this is a good thing, because the 2 is what was causing me the problem. So now the 2 minus 2 right here, that was giving me a 0 on top, and the 2 minus 2 right here, that was giving me a 0 on bottom, that's gone. So I'm left with -1, don't forget that negative from right here, over x plus 2 times 4. Now that I've removed the problem, I'm ready to redo my limit. The limit as x approaches 2 of -1 over x plus 2 times 4 equals, well, let's just re-plug in 2 now, and I'm going to get 2 plus 2 times 4. That's -1 over 4 times 4, which is -1/16. There is my limit. Now, one question a lot of kids say is, couldn't I have distributed that 4 in the very beginning? And I say, yes, you could have. I waited to the end, but you could have distributed that 4 there. But this is how you get rid of these fraction problems, right? These fraction within fractions. Get a common denominator on top, clean it all up. Instead of dividing by the denominator, multiply by the reciprocal, and something will cancel out that helps clean up the problem. All right, here's another one with square roots. Let's see what happens here. Remember, first thing you should always do is just plug in the value for x. So that's going to give me the square root of 8 plus 1 over 8 minus 4, and I get the square root of 9 over 4, which is 3/4. Well, there's nothing wrong with that. That's a number. There's my answer. So sometimes we get so caught up in working about these harder problems where we have the 0 over 0, we forgot that sometimes you just plug in the 8 and it works out nice. So don't forget about those problems easy. I just threw one of those in there to make sure you're understanding. All right, here's another one here with square roots. Let's see what happens when I plug in 0. I get 0 plus 1 in the square root minus 1 all over 0. Well, that's going to be the square root of 1 minus 1 on top, which is 0, divided by 0 and up. Okay, once again, I get my problem. As I've been saying throughout this whole video, when you get this double 0, that means there is an issue that you need to remove. So here's how I'm going to do that. I'm going to take my current function, and I'm going to multiply by the conjugate of the square root. So the idea here is I want to multiply this guy by 1. So I don't really want to change him, but I want to multiply by the conjugate. All I'm going to do is multiply by the square root of x plus 1 divided by the square root of x plus 1 plus 1. So notice that I left the inside the square root the same, I left the 1 the same, all I did was change this negative to a positive. Now since I multiplied the top and bottom by the same value, I'm not really changing anything at all, I'm just simply multiplying by 1, but what I'm going to do is get rid of the problem, and you will see how that will happen. It just takes a little bit of time. Alright, on top, I got to distribute here, I got to do a little bit of foiling, right? I have a binomial times a binomial, so I get the square root of x plus 1 times the square root of x plus 1, which is just x plus 1. That was simple. On the outside, I get the square root of x plus 1. On the inside, I get a negative square root of x plus 1s, and those cancel, which is why I chose to multiply by the conjugate, because the inside and outside terms always cancel. And then I got negative 1 times positive 1, which is negative 1. So that entire top, as ugly as it was, simply multiplies out to be x plus 1 minus 1. Now the denominator, unfortunately, I'm just going to leave as x from right here, times the square root of x plus 1 plus 1. Not really a whole lot I could do with that. Now, let's see what happens here. First thing that's going to happen is the minus 1 and plus 1 cancel. So I get x over x times the square root of x plus 1 plus 1. And then what happens is now the x's cancel. That was my problem. See, that was creating the 0 on top and 0 on the bottom, because if x is 0, then I get that 0 on top and bottom. But I've now gotten rid of that problem, so my numerator is 1. My denominator is just the square root of x plus 1 plus 1. Now that I got rid of that problem, I can find the limit of this reduced, cleaned up answer, which is 1 over the square root of x plus 1 plus 1. Now let me replug in 0. I get 1 over the square root of 0 plus 1 plus 1. And let's see here. That's going to be the square root of 1 plus 1, which is really just 1 plus 1. So I get 1 over 2. There is my answer. Very, very, very nice and very, very, very simple. Hopefully that made sense. Okay, so I multiplied by the conjugate, and by doing that, I had to do some algebra, but throughout that algebra process, I got this problem right here to cancel out, and that made the problem a lot easier. All right, so here's kind of the dealio. Let's do one more here. Another square root problem. When I plug in 0, I get the square root of 7 minus the square root of 7 over 0, which obviously makes 0 over 0. So again, a lot of kids don't like these square root ones. That's why I'm doing another one here. So I'm going to take what I currently have, I'm going to multiply by the conjugate, which is going to be the square root of 7 minus x plus the square root of 7, divided by the square root of 7 minus x plus the square root of 7. So notice it's this sign right here that changes. Don't change the sign inside the square root, please. All right, when I multiply this side, you just got a FOIL on top. Square root of 7 minus x times the square root of 7 minus x is 7 minus x. The outside and the inside terms will cancel because one is a positive square root of 7, square root of 7 minus x. Another one is a negative square root of 7, square root of 7 minus x. Those cancel, which is awesome. And then square root of 7 times the square root of 7 is going to be a minus 7. All divided by x, and then unfortunately, guys, not a whole lot you could do with that denominator. Just kind of leave it the way it is. And let's see here. First thing that's going to happen is the 7's cancel on top, and I get negative x over x times the square root of 7 minus x plus the square root of 7. Now the x's cancel, and that's exactly the problem I needed to get rid of. So I got a negative 1 on top, and on the bottom I got the square root of 7 minus x plus the square root of 7. Now what happens is I got rid of that problem. I could redo this limit with this nicer, cleaned up, no problem function, and I should get a nice, clear answer. So I plug in 0. That's going to give me the square root of 7 plus the square root of 7. Once again, 7 minus 0 is just going to be 7. And that's negative 1 over 2 radical 7. Again, radical 7 plus radical 7 is 2 radical 7. Not a bad answer, but I'm going to get rid of that square root in the denominator. And that gives me negative radical 7 over 14, because radical 7 times radical 7 is 7, times the 2 makes 14. So there's my cleaned up answer. Okay, so here's the idea. What do you get? Sorry for the little typo there. What do you get when you get a 0 on top and bottom? All right, when you get this 0 on top and 0 on the bottom, 3 kind of strategies. try to factor. Factor the top, factor the bottom, get something to cancel. Once you get something to cancel, replug back in for x. If you see the double fractions, fractions within fractions, get a common denominator and combine. Get a common denominator, combine things, and something will cancel, I promise. If you see square roots, and you have this issue, think about multiplying the numerator and the denominator by the conjugate. That will always help get rid of the problem. So these are the three scenarios that occur with the 0 over 0. So, quick recap. Remember, when you approach one of these problems, first thing you got to think about is, hey, just plug it in for x, see what happens. If you get an answer, you're done. Easy. If you get a 0 in the denominator and a number on top, that means your limit does not exist. That's fairly easy as well. Last scenario is the dreaded double zero. That's obviously where we're going to spend the most work practicing in class. But please make sure you understand the three different scenarios that can happen with the double zero and how to handle each of those. Hopefully you understand all that, and then finding limits is actually pretty simple.